Well, thanks for tuning in to another physics lesson with Mr. M. In today's lesson, we're going to be covering how to draw mirror ray diagrams. I'm going to show you 3 different concave mirror ray diagrams and then 1 convex mirror ray diagram. And usually when you have these types of problems, you end up with your object, you've got your mirror, and you have your 2 points, your focal point and your center point. This may also be known as 2F because it's twice the length of your focal point. Now, in attacking these problems, we're going to be using the same method for each ray diagram. And the way that we do this is we always draw our rays from the top of our object. And we're going to draw 3 different rays. The first ray that we draw is we're going to start from the top of our object and we're going to draw it parallel to our baseline. That ray is going to hit our mirror and it's going to bounce off through our focal point. So that's how it's going to reflect. And you want to make sure that you kind of draw it extended. Our second ray, once again, is going to originate from the top of our object. We're going to draw this one originally through the focal point. It's going to hit that mirror and it's going to bounce back parallel to our baseline. And then the last ray that we're going to draw is we're going to draw it through the center point. So we're going to just draw one through the center point. Now my diagram isn't perfectly to scale. What should happen is when we draw these 3 rays, we're going to get an intersection. You can see right there, all 3 of my rays are intersected. What that tells me is that is where my reflected image appears. So the way that we kind of show this is we're going to draw from our baseline down to that intersection. This gray arrow represents the image of my original object. And so what that means is we can compare those objects. You may have to do this for whatever worksheet you're working on or problem that you're working on. It may ask you to classify your image as either real or virtual, upright or inverted, or smaller or larger. I did a whole video on those if you want to check that out. You can find that as well. So we're going to classify this image. First thing that we know is that this image is upside down. So it's flipped. So we call that inverted. And just let me change my color here. So we have inverted image. Our image also lies on the same side of the mirror as our object. So we call that a real object or a real image. And the last thing we want to do is compare size. This image here is clearly smaller than our original object. So we would say that it is smaller. Okay. What I want to do is show you another example, and just to show you, this object here was outside of the center point. Okay, and so when it's outside the center point, we get an inverted, real, smaller image. Now, our object here is now located in between our center point and our focal point. We're still going to use the same method. We're going to start by going parallel to our baseline. It's going to reflect through that focal point. Our next one is going to go through the focal point, hit that mirror and reflect parallel, and our last one is going to be drawn through the center point. What you'll notice here, once again, my drawings are not to scale, but you're going to end up with an intersection of those 3 lines again, and once again that's going to tell you where your image is. So for this one, I'm just going to take the average of those 3 lines and it's going to end up about right there. So what that tells us is for an object that is in between our center point and our focal point, this image is inverted. this image is real, and this image is larger. Okay, so that was in between the center and the focal point. Now the last concave mirror diagram I'm going to show you is when our object is really close to the mirror. It's actually within that focal point. So this is the trickier one out of the three, but our method is going to be the same. Draw your parallel line, hits the mirror, reflects through the focal point. Our next one is we're going to draw it through the focal point. And so for this time, we're going to actually kind of start down here. This is a good one to actually start from the focal point through the top of our image. It's going to hit that mirror, and it's going to reflect parallel. And then our last one is going to go, we're going to start from that center point, and we're going to draw it through the top of our image. When our center point reflects, it actually reflects the same way, so it actually reflects this way. So you're probably thinking to yourself, hey, none of my lines intersected. Well, that's correct. So what we have to do is we have to trace our reflected rays behind the mirror. Okay? And so for our very first one, our reflected ray is right here. So we're going to trace that as if it were to continue on. Normally, I would draw these as dotted lines, but I'm just going to draw it as a solid line. Our second one is parallel. So if that were to continue, we would get it right through there. And then our last one was our center point. So if that were to continue, we would get something like that. And now you'll notice there is our intersection. So that is where our image is located. So when we're really close to a concave mirror, we end up with one thing that we know is upright. We know that it is a virtual image. And we know that it is larger. And this is the reason for normally these concave mirrors are magnifying mirrors, because they magnify your object and it keeps that object upright. Okay. The last ray diagram that I want to show you is if we have a convex mirror. Okay, and for the convex mirror, we have our negative focal point and our negative center. These guys are going to come into play. The same method. Okay, so let me get back to my arrows. We're going to start from the top of our image. We're going to draw it parallel to our baseline. Now this reflection should be reflected out. What actually happens is, and this would be a good time to have your ruler out, you're going to line your ruler up so that it's in line with the focal point. So our reflected ray would actually kind of jut out like that. Our second one is we're going to draw this as if we were trying to draw it through the focal point. So that's where you're going to line your ruler up. So I'm going to do my best job to point this at the focal point. And this ray still reflects parallel. And then our center point, you're going to align your ruler so that it lines up with the center point. And I'm going to do my best to draw this to where that center point is. So something like that. And once again, our center point reflection is going to reflect back exactly the same way. So here we have the same dilemma. Our three reflected rays do not intersect on this side of the mirror. So what that means is they're going to intersect behind the mirror. So what we got to do is we got to extend these reflected rays again. So If this ray were to continue, remember it would have continued through the focal point. Our other ray, if it were to, that reflected ray were to continue, it would be parallel to our baseline. And that center ray would have gone through the center. I'm off a little bit, but you get the idea. And here we see our intersection. So what that tells us is that is where our image ends up being. Okay, and the nice thing about our convex mirror, our image always ends up being the same. No matter where we put our object on this side of the mirror, our object will always be, it will be an upright image, it will be a virtual image, and smaller. It will always be smaller. So these three image types will always be true for a convex mirror. And this is why typically you have your convex mirrors like a side mirror on your car. That's why they have that tagline that says objects in mirror appear closer, are closer than what they appear, because when we get that image, it appears small. So that's what the note stands for. Okay, so hopefully watching this video, it has helped you with some of the problems that you have done yourself. Remember, it's the same method. Draw those three lines and those reflected lines. Where those reflected rays meet, where they intersect, will show you where your image resides. Thanks for tuning in.